Hello everyone, Dev Victoria is here, and I started to work on some bumper game mechanic implementation. And what I would have liked to achieve is that slightly inspired by the Gottlieb's Gigi pinball machine. So these these bumpers are kind of divided into two groups. Two of them is on one side of this river, and another two of them ended up on other side of the river. What I'm thinking is that these two bumpers could be like the bright side on the river, the good side of the river, and this other two could be on the bad side of the river. And if a ball is hitting these bumpers, they are going to light up. And if two of them are lighted up, then the score is going to be doubled for as long as they are both lit up, basically. And if these two are lit up, then the score is going to be half. And if this bumper here on the good side of the forest is lit, but then this bumper on the bad side of the river has been hit, then this turn off the light of this bumper. And same with these other two. So I wanted to make a bit difficult to light both up a bit. And I'm not sure if this half score will be the final penalty for this behavior, but we will see. And in this video, what I would like to do is what things I've implemented to make sure to light up these bumpers and to turn off the light on the corresponding bumper. So I created a switch light data outdooring script for this, and this tells the system on which bumper mushroom the light should be turned on, and on which bumper mushroom the light should be turned off. And this is on the bumper moving part where the trigger physics shape is. So let's take a look at the bumper mushroom. It has a material override where I can turn on the emission of the bumpers. Basically, the bumpers got this emissive shader graph material, and this mask emission shader graph. Now there is a bug with the shader graph editor itself. So if I mark a property, this bumper emission, to be hybrid per instance, then it is going to freak out. Basically, as far as I know, this is going to be corrected in future versions of Unity. But for now, this is what we have to live with. So basically, this property is used to turn on the bumper emission. It has a bumper emission mask. If it's turned on, then this will light up. And then finally, the emission value is going to be calculated using this bumper emission mask, which has a little circle in the corner here. So I'm going to close this so that it won't close any distraction. So the most important thing, if I increase this emission value on the material, I don't quite understand why nothing happens. Now let's increase it on the bumper mushroom. Let's say I am increasing this. As you can see, it is going to be light up. So let's just revert this to 0. And let's see, so we got this material override on the bumper mushroom, and we got this light state data outdooring component to state the light state on or off. Currently is off, and the on emission value and the off emission value. So, and also I would like to point out one thing. We have two switch light data components here, and on one entity we can have at most one component of the same type. But if we want to handle more components of the same type, we have to convert these into a dynamic buffer. But we can do this during the entity conversion. So let's see the code of all of this, how this is going to happen. So the light state is very straightforward. It's just a light state data, has a light state component, on emission value, off emission value. The outdooring component can be generated automatically. So there is no big deal here. So let's see the switch light data. We've got an iBuffer element data, light object and light state. And basically we are going to get in the switch light data outdooring, we are going to get a light object and a requested light state. And we are going to have a dynamic buffer of switch light data buffer, and we can ask if the entity has a switch light data component on it. And if it has, we can get the buffer. If it doesn't, then we can add the buffer here. And then we can add this buffer, this new light object. So in this way, we are going to handle, in fact, our switch light data buffer, but the way we are asking it from the user in the editor is a bit more user-friendly, in my opinion. So let's see the trigger light switch system. This trigger light switch system is going to just mark the light state data on or off. It doesn't adjust any material overrides because I think the light state data system is going to handle that. So first we are going to activate the switch light data to set the light state on or off. So practically turn on off the light, but the action is going to be handled by the actual light switching is going to be handled by a different system. So I kind of hope you understand what I'm getting at. So in the trigger light switch system, this is going to be running in the fixed step simulation system group because we are going to handle triggers. And the entities is scope which contains the switch light data. And we are going to create a trigger light switch job. We are going to get the ball tag to identify which is the ball, which is not the ball. The switch light data buffer from entity and the light state data component from entity. And we in the trigger events job is very straightforward. We determining which is the ball, which is the light switch, and we are going to handle ball light switch collisions or trigger activation. We get the light switch data entity and we go through this switch light data buffer, and we get the light state data and we get the requested light state, and we are just setting the requested light state to be the light state of the light state data. So if it's on, then we are turning it on. If it's off, then we are turning it off, and we're writing this back. So this is not a complicated system at all, very straightforward. And then the light switch system is going to do the actual light switching. And this is very straightforward too, very simple. So we are going to process this light state data, and now we are affecting this material override based upon this on or off emission value basically. So the bumper emission float override, actually the override, if you are defining a material override on a property in this material override asset, it generates a material override script, and in this case this is going to be the bumper emission float override, and this is going to be an I component data, and during conversion this component data is going to added onto an object, onto an entity. And so we have to set this bumper emission float override based upon what's in the light state data. So this bumper emission override float value, so this just has a float value here. Value should be, if the light state is on, then the on emission value, otherwise the off emission value. So this is very straightforward again. So let's see how this is working. So let's grab our test ball, and as you can see I just turned off this turned on this light on this bumper, and now I turned on the light on this other bumper. If I hit this one, that it's turned off the light on the corresponding bumper, and if I hit this, then it turns off the light in this other bumper, and so on, etc. So it works. The score modifier calculation and display of the score modifier, it is going to be in a later video, so you don't worry, you will get the information about that. But for this video, I think this is the only thing I wanted to say in this video, so this is the end. I hope you enjoyed it and perhaps learned something from it, and maybe you can use this as an inspiration for your project. And I hope you enjoyed it, and see you in the next one. Goodbye for now.